Greetings, I'm Dev the developer. Every meaningful program needs to make decisions. Until now, our code just runs top to bottom the same exact way every single time. In this lesson, we're going to change that. We're going to look at the if statement, comparison operators, logical operators, and a compact shortcut called the ternary operator. The foundation of all of this is a concept called a condition. A condition is any expression that evaluates to either true or false. In C#, that type is called a bool, short for Boolean. And the if statement runs a block of code only when that condition is true. Here's the basic structure. The condition lives inside the parentheses. The code that should run when the condition is true goes inside the curly braces. If the condition is false, that whole block is just skipped. Nothing happens. Right now, age is 17. So age greater than equal to 18 is false. Run it and you'll see nothing. No output at all. The program ran. It just had nothing to do. That's fine if we only want to act when the condition is true, but usually we want something to happen either way. That's what the else is for. With an else, one of the two blocks will always run, never both, never neither. The if-else covers every possibility. 17 is less than 18, so we hit the else clause. Change age to 21 and the other branch runs instead. The two outcomes cover a lot of ground, but sometimes you need more. When you have multiple possible cases, you can chain else-if clauses between the if and the final else. C# evaluates them in order and runs only the first one whose condition is true, and then skips the rest. A grade converter is a classic example. Notice something about the ordering here. We start at 90 and work down. We don't need to write score is greater than or equal to 80 and score is less than 90 for the B branch because by the time we get there, we already know the score is below 90. The first check failed. Each else if is implicitly saying that all of the previous conditions are false. If we run it with a score of 85, 85 fails the greater than or equal to 90 check, but it passes the greater than or equal to 80 check. Grade B prints and the rest of the chain is skipped entirely. Let's run through all the comparison operators. You've seen most of them already, but here's the full set. Double equal checks if two values are equal. Exclamation equal checks if they're not equal. Less than, greater than, less than or equal, greater than or equal. All of them give you back a Boolean. Here's one that trips almost everyone up at some point. A single equal sign is assignment. Double equal is comparison. If we write if age single equal 18, C# will give you a compile error because you can't use assignment when a Boolean is expected. It's probably the most common early mistake people make with conditions and just something to keep in mind. Sometimes one condition isn't enough. You'll need to check two things at once or say either of these will do. That's what logical operators are for. The first one is the double ampersand, the AND operator. Both sides have to be true for the whole thing to be true. Temperature greater than 65 is true. Sunny is true. Both are true, so the condition passes, but change sunny to false and neither condition can save you, so both have to be true to hold. The second operator is the double pipe, the OR operator. On most keyboards, the pipe character is shift and the / key up near the enter key. With OR, At least one side needs to be true. Has ticket is false, but is VIP is true. One of them is true, so the condition passes. You don't need both. The third one is the exclamation mark, which is the not operator. It flips a bool. Put an exclamation mark in front of something true and it becomes false. Put it in front of something false and it becomes true. Is logged in is false. The exclamation mark in front flips it to true, so the block runs. It reads almost like plain English. If not logged in, show the message. One more thing about double ampersand and double pipe before we move on. When C# evaluates these, it stops as soon as it knows the answer. With double ampersand, if the left side comes back false, the right side never runs. The whole condition is already false. C# stops there. With double pipe, if the left side comes back true, C# skips the right side. Already done. This is called short circuit evaluation, and it is not just performance trivia fact. It changes what is actually executed. Is adult is false, so the double ampersand short circuits right there. Has valid ID is never touched. Not its result is ignored, it just doesn't run. That's why order matters in a condition. Put the check that is cheapest or most likely to fail on the left side. If it fails, the right side never has to happen. The same logic applies to double pipe in reverse. If the left side is already true, the right side is skipped entirely. You'll find yourself thinking about this more often than you'd expect. There's one more tool in this space worth knowing, the ternary operator. It is a compact, one-line way to choose between two values based on a condition. The syntax is condition, then question mark, then the value if true, then a colon, then the value if false. That's exactly the same as writing an if else that assigns two results in each branch. The ternary just does it in one line. Use a ternary when you're picking between exactly two simple values. If your branches need multiple lines or complex logic, use regular if else. Readability matters more than brevity. Let's write something that uses most of what we just covered. We'll ask for a temperature and classify it. There's the if-else chain classifying the temperature. And then a ternary at the end making a jacket recommendation. We can run it and that if, else, and ternary are all working together. This is the structure you will reach for every time a program needs to make a decision. Conditions are how your programs stop being a straight line and start doing something different based on what is actually happening. Get comfortable with writing them and testing both branches and build the temperature classifier from this lesson. Don't just watch it, do it.